The Taylor series for a function f about x equals 1 is given by this right here and converges to f of x for this means right here. This means that we are centered at 1. So centered at 1 is less than r, where r is the radius of convergence of the Taylor series. Find the value of r. So for letter A, let's do the ratio test. Limit as n approaches infinity of, let's switch to this, writes a little nicer. We have 2 to the n plus 1 over n plus 1, and then x minus 1 to the n plus 1. Then we're going to multiply by n over 2 to the n and x minus 1 to the n. That leads us to the limit as n approaches infinity of the absolute value of, there's an extra 2 on top, and then we have an extra x minus 1, and then n over n plus 1. Well, the limit on n is going to be 1, so this goes to the absolute value of 2 times x minus 1 is less than 1. So now we know negative 1 has to be less than 2 times x minus 1 has to be less than 1. So negative 1/2 less than x minus 1 less than 1/2. So we're centered at 1 with a radius of 1/2. And A says, what is r? R is equal to 1/2. Letter B, find the first 3 non-zero terms in the general term of the Taylor series for f prime, the derivative of f. All right, let's try that. Letter B. Well, f is given by this series right here. So we're starting with 1. 1 plus 1 is 2, so we're starting with a positive value. It's going to be 2 to the first over 1. So 2 times x minus 1 to the first, and then minus, it's going to be 2 squared over 2 times x minus 1 squared, and then plus 2 to the third over 3 times x minus 1 to the third. And it says the first 3 non-zero terms, we got that. So that's really what f is. And then we want f prime. So f prime of x is going to be 2 minus, that's going to be 4 x minus 1 plus 8 x minus 1 squared. So plus plus negative 1 to the n plus 1. And then that's going to be times 2 to the n, and then x minus 1 to the n minus 1. Letter C, the Taylor series for f prime about x equals 1 found in part B is a geometric series. Find the function f prime to which the series converges for the absolute value of x minus 1 is less than r. Use this function to determine f for absolute value of x minus 1 less than r. So they're saying that B is a geometric series, and we're just going to find a function for f prime. So f prime of x is equal to, we have a sub 1, which is 2 over 1 minus, and it's going to be a negative, so let's go plus, and r is 2 and x minus 1. That's 2 over 1 plus 2x minus 2. That's going to be 2 over 2x minus 1. And it says use this function to determine f for the absolute value of x minus 1 is less than r. So let's do this. Let's integrate both sides. So now we're going to integrate f of x is equal to, oh boy, let's see. That's going to be the natural log of the absolute value of 2x minus 1. And we could do this using u substitution, but we know that when we take the derivative of natural log, it's going to be sent down to the denominator, but the chain rule is going to give us that 2 on top. So I guess we put that there. Now we need a point to find the c. Well, a really nice point would be for f would be 1, 0. Because if you plug 1 in for x, all of the terms go to 0. So 0 is equal to the natural log of the absolute value of 2 times 1 is 2, minus 1 is 1. plus c. So natural log of 1 is 0, so c is 0. F of x is equal to the natural log of the absolute value of 2x minus 1. The Maclaurin series for a function f is given by all of this and converges to f of x for absolute value of x is less than r, where r is the radius of convergence of the Maclaurin series. A. Use the ratio test to find r. We have the limit as n approaches infinity of the absolute value of negative 3 to the n, because we're going to add 1 to this, and that'll just be n, over n plus 1, and then x to the n plus 1, times n over negative 3 to the n minus 1, and then we're going to have x to the n down here. We have the limit as n approaches infinity of the absolute value of, there's going to be an extra negative 3 on top, extra negative 3 here, and an extra x, and then times n over n plus 1. Well, now we have the absolute value of negative 3x has to be less than 1. So negative 1 is less than, this negative doesn't matter. 3x is less than 1, divide by 3. Negative 1 over 3 is less than x is less than 1/3. It says find r. R is equal to 1/3. So we're centered at 0, and we have a radius of 1/3. So there's letter A. There's A. Let's go with B. What does B have to say? Write the first 4 non-zero terms of the Maclaurin series for f prime, the derivative of f. Express f prime as a rational function for the absolute value of x is less than r. So let's do f prime of x, which is equal to, and I'm looking at, it says the first 4. So we have 1, 2, 3 terms. We're going to have to find one more. So the derivative of the first term is 1, then minus 3x to the first, plus 9x squared. Let's see, we've plugged in 1 to this one, 2 to this one, 3 to get that one, and we have to plug 4 in. So 4 minus 1 is 3, so that we're going to have minus 27 x to the 4th over 4. So that's going to give us minus 27 x to the 3rd when we take the derivative. So write the first 4 non-zeros, got that. The derivative of f, express f prime as a rational function. Well, if they're looking for a rational function, that means this is a geometric series, where a sub 1 in this case is 1, and r is negative 3x. So the rational function, f prime of x, is going to be 1 over 1 plus 3x. Letter C. Write the first 4 non-zero terms of the Maclaurin series for e to the x. So e to the x is equal to 1 plus x squared over 2 factorial plus x to the 3rd over 3 factorial. Use the Maclaurin series for e to the x to write the 3rd degree Taylor polynomial for g of x equals e to the x times f of x about x equals 0. So e to the x times f of x is equal to 1 plus x squared over 2 factorial plus x to the 3rd over 3 factorial, and all of that times, so I just need to be able to get, let's erase this, the 3rd degree. So x minus 3 halves x squared. X minus 3 halves x squared. I need the next one, so plus 3x to the 3rd. Plus 3x to the 3rd. That's probably all we'll need here. Let's distribute the 1 through. So we get x minus 3 halves x squared plus 3x to the 3rd. Let's distribute the x through. And we get x squared minus 3 halves x to the 3rd. And if we multiply times x squared, we just get x to the 3rd over 2, positive. So the 3rd degree is x. We have negative 3 halves plus 2 halves is negative 1 half x squared. And let's see, we have 6 halves. Right there, there's 6 halves minus 3 halves and then plus 1 half. So 3 halves plus 1 half is 4 halves. That is going to be plus 2x to the third. And here we have the rubric and all the points that go along with the rubric.